Hey everybody, welcome back to Nikki T Live. I'm your host Nick Taylor, and today I'm hanging out with Dillon Mulroy. Dillon, how you doing today?
I'm doing well. Thanks for having me.
Yeah, no, I know we talked about this a little while ago, and we had to reschedule because I was mentioned to you I had to pick my kids up at camp, which was kind of an important parenting thing. So thanks again for rescheduling. Um, yeah, so for folks who might not know who you are, I guess what are you up to these days? If you want to talk about how you got into tech or like some cool places you've been working at, I know people always love to hear about all that stuff. So
Yeah, sure. So currently, I am employed at Vercel, basically working in full stack TypeScript. I work on a team called the Lifecycle team. We kind of oversee ownership over accounts and teams after the sign up occurs.
okay,
So a lot of things around upgrades, downgrades. I've also recently taken over some responsibility over our domains product and working on that. But prior to that, I've had a somewhat interesting journey to get here. I I graduated college in 2014 or 2015, and
okay,
I graduated from a tiny like liberal arts no name university in the mountains of Pennsylvania, like
okay,
3,000 students. The town has 5,000 people, including the students. A single traffic light. CS
okay,
program wasn't great, but for whatever reason, State Farm hired CS interns from us, and I managed to land that as a sophomore, and then had gone back a couple summers, and then my first time full time job was doing enterprise Java at State Farm with a little bit of JavaScript on the front end.
okay, cool.
Um, yeah, so moved out to Phoenix, Arizona from the East Coast for that first job. Then kind of ended up getting screwed out of a raise and promotion and found another job, which took me back to the East Coast. Went to
Okay,
Maryland, where I worked at a tiny defense contractor for basically all of the three-letter intel communities,
okay,
or excuse me, intel agencies. And that was a super cool job because we got to bid on like good greenfield work that had like cool mission impact. And that's where I really like dove into like Node and JavaScript
okay,
deeply. And I would say that's like as much as I like to be angry at TypeScript on Twitter, like Node and TypeScript and JavaScript are my bread and butter. I've been writing React since 2015, like the days of mixins and class
yeah, yeah,
components. So I got to do a ton of React and a little bit of Go at that job. And one of the last contracts I was working on making a charting library. And at the time, one of the more popular React charting libraries was Victory Charts by Formidable Labs.
yeah,
I couldn't use Victory Charts because it only renders to SVG, and there's a ton of radar data, like
okay,
tens of thousands of points, and it just doesn't scale. So I was trying to implement basically Victory's API, but rendering to Canvas and being
okay,
GPU accelerated. And I was going back and forth on GitHub with the maintainers of Victory, which coincidentally, I'm not sure if Ken Wheeler was a maintainer at the time, but I ended up talking to him about a
okay,
bunch of this. And at one point, he was just like, you should apply. So I did it. Ended up working at Formidable for 3.5 years. I mentioned before we went live, but like working at Formidable was like the biggest accelerator for my career, like without a doubt. Like
yeah,
one, it's a consultancy. So like the business model of consulting, which is actually the same business model as defense contracting, which I had done for three
okay,
years, is companies will hire you, come in, you build something or fix something, almost always fixing something. Consultants don't generally get brought in when things are happy go lucky.
yeah,
Um, so like on one side, I had to learn very quickly to build like my catalytic or soft skills. Like I, I don't know. I tweet often that like the hardest problems in tech are not algorithms, caching, performance. It's people, process, and
oh
organization.
yeah, totally,
And
yeah,
that was like half the problems we were solving as a consultancy was like, well, this team needs to talk to this team, and like we can take care of the tech debt. Like that's fine, but
yeah, yeah,
so that was really rewarding getting to see all those different companies getting like I did stints at Google, I did stints at tiny startups at Fortune 500. So I've kind of been privileged to see a lot of different uh, engineering cultures and how different companies do things. And at the same
yeah,
time, Formidable was back in like the 2017 to 2021-ish window, like was just stacked with some of like the best open source
Oh yeah.
devs. And like I got to cut my teeth learning from them, and they were, you know, yeah, very privileged to have got to work with them and learn from them. Then from there, I played the startup game for 2 or 3 years. I did a tax credit startup that basically failed miserably, and then I went to an institutional DeFi
Okay.
company, which also unfortunately did not succeed. And then I landed at Vercel at the start of this year. Um,
Oh, cool.
so yeah, that's kind of like my work history.
Yeah, no, that's awesome, man. No, thanks for sharing. Yeah, we were talking briefly a bit. Like, I remember those formidable years. Like, I remember trying to remember what was the presentation software called. It had like a little Pac-Man at the bottom when you change the
Oh
screens.
yeah, it
Uh,
spectacle.
Spectacle. That's it. Yeah, Ken made that, I believe. But yeah, we were. I don't know Ken well. I met him at React Miami this year in Dax's backyard, which was that was a whole definitely a fun day. I'll leave it at that. But yeah, no, he's definitely a character, but he knows his shit, and he's like, again, I don't know him
100%.
super well, but he, even though he seems like this big tough guy, he seems like a very kind person at the same time. At least
For
that's
sure.
the impression I've gotten. It's like, but
Yeah,
yeah,
I had I believe I had like a small like 1 or 2 month overlap with Ken while he was still at Formidable before he left to go to I think his current job. But
yeah,
yeah, so I didn't get to interact closely with him in my day job, but like just seeing like his demeanor and messages in Slack and all that, like one like genuinely one of the most talented like people, and like he can he's very good at putting his finger on like where the pulse is at and where things are going. And then two, like his personality online is his personality just in real life.
yeah.
So I haven't got to hang out with him in real life, but yeah, very much a fan of Ken.
Yeah. No, I'm hoping to meet him at another conference. Yeah, no, that's super cool. No, so you worked at like some cool places, and like Vercel is obviously pretty well known at this point. And uh, yeah, so that's cool that you're working. You said, what was the team you're working on again over there? Uh, Life
I'm
cycle,
on,
was it?
yeah, it's called the life cycle team. And we essentially own the life cycle of
Yeah,
basically the user after sign up to hopefully not churn, but kind of,
yeah,
making sure that they can have a good experience finding our products, navigating the dashboard, making sure our upgrade and downgrade flows are working and are easy to use, things like that.
yeah.
And then more recently, actually within the past week or so, I will be taking over the domains product as the tech lead.
Okay,
So hopefully,
cool.
that's to my knowledge, our oldest product. Like some of the code is like 7 or 8 years old, and we have a lot of
Okay.
tech debt there. So working to improve that and hopefully grow it in the future.
No, that's cool. That's cool. And no, that's cool. You mentioned the life cycle team because, like, whenever people think about like tech companies, it's like, okay, can I deploy and stuff? And like, there's that whole part of like retaining your customers and like just it is super important. But like, you don't really hear tech Twitter talking about it too often.
Yeah.
Normally, at least maybe in my Twitter bubble. But so yeah,
It was a good fit for a team for me to end up on because like I've always wanted to have good data around the features I ship. Like I want to be able to like empathize with my users, right? I think that's something that's easy to like stray away from what the actual user experience is as front end devs.
yeah,
And one of the core things we work on is like kind of like analytics and where are our users getting caught up, where are they having bad experiences, relaying metrics to other product teams. So um, yeah.
yeah. No, that's cool. That's cool. And yeah, so you've been like you were saying, you got into React and like TypeScript pretty early. I kind of have a similar path. I started doing React in 2015, and I was working at like a Microsoft shop, so they were like early days of TypeScript. Like, I don't know. I still, the impression I get from people just approaching TypeScript is they think it's fairly new still, and it's like it's been around since 2012, like which is hard to believe, but yeah, no, I it's definitely changed the game for me for doing front end and back end if you're in JavaScript land. Like uh it is the types though can be misleading sometimes. I was doing a live stream last week and I I was just doing this example. We're doing like I was hanging with Sam Julian from Writer, and so I was using their SDK to just like call like their models and stuff to just get some information back, and
Mhm.
I had the wrong types on the request response. It was like Next.js pages router API endpoint, but I had invalidly put the wrong like next response and next request, and then like no joke, for like 30 minutes I was like, why isn't this working? Like, where's like, shouldn't the body be on this? And I was so confused, and like that was just my own fault obviously, but it's just kind of like I bring it up because like TypeScript's amazing, but like when it comes to like APIs or like just, I mean, in this case, I took an example and I didn't have the types right away, so it is my fault.
Right.
But like in terms of like API endpoints and stuff, so like you have stuff like TRPC and all that, and you need that code gen to keep things in sync, because like you could be like everything compiles and then you go to prod and it's like, why is everything undefined and stuff? And I feel
Yeah.
like you probably run into some stuff like that too. Or,
Yeah. So up until my job at Scalum, which was the job before Vercel. I actually
okay,
found out on January 2nd of this year that we were going to close down in March. And coincidentally, my manager had posted on Twitter that she was hiring for her team at Vercel. And I had worked with
okay,
her at Formidable. And we've been talking for a couple of years, going back and forth about me eventually potentially ending up at Vercel. So like the time just ended up right. I interviewed, and fortunately that went well.
yeah,
But the previous job, Scalum, that's where I really kind of it's probably the best experience I've had as far as technical growth goes.
okay,
Um, because that company did basically everything in OCaml. Like up until that
okay,
point, like I had a somewhat high level understanding of what functional programming was, and I had an appreciation. I've always had like an appreciation for the concepts around functional programming, like
yeah,
as far back as like that job at the DoD. Like I found Lodash and like specifically Lodash's chain API, like being able to build up like these pipelines of like do this pipes into this one pipes into this one, basically building up like these immutable pipelines of data transformations. It's just like clicked and made sense in my head. And like so like very early things like Redux I got really into, and state machines,
yeah,
and let's see here. What else? They're my favorite conference talk of all time. I'll see if I can grab a link here in a moment. But
yeah.
it's a talk by Lee Byron, who is a was is I'm not sure if he's still at Meta, but he helped build Immutable JS, which has
Oh
since
yeah, yeah, I
kind of fallen
remember.
out
Yeah.
of favor in for Immer. But they both kind of use similar ideas. But he gave a conference talk on Immutable, and more specifically, the like persistent data structures that Immutable uses behind the scenes, and talked about like how Clojure uses similar data structures to make like immutable copies. Like they use structural
Okay.
sharing. So when you do like immutable updates, it's not like in JavaScript or TypeScript where you copy the whole object, right? Like
Yeah,
it
yeah.
only changes the bits that you need to change. And like that just blew my mind. And like to this day, I think that conference talk has aged incredibly well. Um, what else? Yeah, I would say then obviously got into TypeScript around 2018-ish, 2019.
Okay.
Um, and like kind of really never looked back. Like once it
Yeah.
clicked, like what a type system could do for me, I was just like, why would I do anything else?
Yeah.
And up until this point, I had some experience writing profession or Java professionally, and then I did a relatively large project in Go. But Go has such a similar type system to TypeScript that like basically what I thought of as types and type systems, I thought it was
Yeah.
just like Go, TypeScript, Java, and they all have Java's a little bit different than Go and TypeScript because they're structural. But like
Yeah.
when I finally started working on Camel, which uses a Hindley Milner based type system, like
Okay.
my mind like melted. And for people who don't know what that means, it's
I
basically
don't know what it means, so I'm definitely curious.
yeah. So you can get away in OCaml and ReasonML and other languages that use Hindley Milner type systems, which Hindley Milner, that's two, I guess, computer scientists from back in the day who discovered like this type system and, working with like lambda calculus and all that.
Okay.
Um, but you can get away with basically not annotating like any of your types, and
Okay.
it will have rock solid 100% guaranteed type safety, which is unlike
Okay.
TypeScript. TypeScript's type inference is totally different than what
Okay.
Hindley Milner does. Now I still like to annotate my types because one, it's like good for documentation, especially at like top level APIs and
Yeah.
stuff. um, but it just like the worst parts of TypeScript, minus like some of the really insidious, like glaring gotchas that can cause unsoundness. So there's two different types of type systems, right? You have sound type systems, you have
Yeah.
unsound type systems, and that's kind of pretty broad. There's
Yeah.
definitely ways to describe different type systems, but like sound and unsound, and what it means for a type system to be sound is that if you compile and your program type checks, you're guaranteed at runtime not to have type errors,
Yeah.
which this is not true of TypeScript for a variety of reasons. But the worst parts of TypeScript, besides those, is like just how verbose it is, how like challenging it is to like actually describe your data. Like if you get into the world of like having to use like map types and all
Yeah.
these type helpers and deeply nested generics, and then you have like the ternary expressions, like it's hard to nail down the types you want sometimes, and like it
Oh
can take
yeah.
a lot of effort. And it sometimes it's faster just to take the escape hatch, right, and throw your any in there and ESLint and ignore.
Yeah.
um,
Yeah.
but with languages like OCaml, ReasonML, Gleam, you can just go and write your code. The type system like stays out of your way. Like it genuinely works for you. Um,
Okay.
I think you get probably a similar experience from Rust. It's not the same type system. It doesn't have that same level of type inference, but um, yeah, once you experience a type system that is actually good and is there to help you do the right thing constantly and doesn't slow you down, like it's just like light bulb moment, and it's so hard to go back.
Yeah, no, no, that's super fascinating. And also, just want to say hey to KMel95 and Jose F. Biden in the chat there. Um, So I'm curious in terms of OCaml because like typically like I mean I write types in TypeScript obviously, but I try to infer as much as possible, or I also like you know there's lots of great helpers like component props, omit, or like even getting the return type, and then like just so I don't I do it for a couple of reasons. Well, one, I don't think you should like recreate the literal type that exists there if you can infer it somehow, or even alias it to use it elsewhere. But I'm curious in OCaml how that works. Then is it just like the inference is just rock solid, and that's why like as soon as like I don't know, as soon as primitive types is pretty easy to infer, but like if you I don't know, you create some complex object in OCaml, if you were to do that in TypeScript too, it would infer that type. But I guess what's the difference exactly? I probably
Yeah,
need that
yeah,
light bulb moment. I probably have to mess around
yeah.
with OCaml, I think. But
So I can also pull up. I gave a talk on this or stuff around this that I can pull up and share my screen here in a bit. But so the first thing I would say is TypeScript doesn't necessarily infer types directly, like in a nominal sense.
yeah,
TypeScript like infers structure from the code, which is very, very different than like inferring a nominal type, which would be like a named type. So that's how
Okay, so you mean
OCaml
like
works.
duck
It can,
typing kind of in TypeScript? Is that what you mean? Like where it's like it's got these
uh,
properties, so structurally it is whatever that is?
yeah, so that's what I mean by a structural type system. Like, it's the same thing
Yeah,
in
yeah.
like TypeScript and Go, where like in Go you can define like some interface, and as long as the structure passing into a function that takes that interface partial or matches that structure, like you're good to go. Where in OCaml, like
Cool.
you wouldn't do that. You would like name like, hey, I'm gonna pass in like this type.
Okay.
So you still declare types in OCaml. So let's say we had like a to do, right? You would have like type to do, and you make it like a record type. You have ID done as a boolean, whatever on it.
Okay.
But then beyond that, like you don't have to annotate the objects that you use that are to dos if you don't want to.
Okay.
So the way it kind of works is the type system will know about the types you've defined. And as you
Okay.
use them, it does like this unification process where it's like, okay, I know about these types. And I see here in this code, you accessed a property called uh, is done. And I
Yeah.
know that to do is the only type that I have knowledge of that has is done. So this must be a to do.
Oh, okay. Okay. Okay.
There's situations where you can get in where you do have to annotate types. Like maybe you have two different types that have some commonality and you don't use them in specific enough ways. There you're going to want to annotate it because it won't be able to unify down to a single type, and
Okay.
that's what powers the inference. It's basically based on usage. Um,
Oh, okay. That's super interesting.
so that's kind of how that works at like a high level. Um, I would also say this might surprise you. I am very much in the camp of when it comes to return types in TypeScript, always annotating return types
Okay, so
because
you're team Primogen.
yeah. So and this is because of how TypeScript does inference. One, I like annotating return types because it declares my intent, right?
Yeah.
I I should also I've talked about this a couple times on my stream and in my conference talk, but like when I started writing in TypeScript, I naturally like changed the way I program and problem solve. And I still do this to this day is before I sit down and solve a problem now, like where before I probably would have just started slinging code. I like think about my types. I model my domains on types
Yeah.
and I model the problem around types. And I start at types. I think about it in types. Like I want to make invariants in like unrepresentable states, like literally unrepresentable by the type system.
Yeah.
So I kind of start there. So I think that kind of naturally guides me to being in the camp of wanting to annotate return types because like up front, like I want to declare my intent and program against my intent because
Yeah.
there's
Yeah.
I, I know for like myself, like if I don't do that and I just start writing a function and I might get distracted or I might realize I have to do X, Y, and Z things and maybe that shouldn't happen in this code, but I do it anyways. And then suddenly like the returned inferred type is just like way larger in scope than what I
y-
ever intended, or the
Yeah.
function's doing more. Where if I just start like this function is doing this thing and this is the return type, like that is my contract that I like have to
Yeah.
program
Yeah.
myself to. Um, so yeah, I that's why I like annotating stuff in TypeScript beyond just TypeScript sometimes
Yeah.
being bad at
No,
inference.
yeah. No, that makes sense. I do type the return type sometimes, but I will be honest, I don't do it all the time. But it's to your point. I like what you said about that though, about like just this is my contract and it's not changing unless there's like you literally say, okay, well, this is going to change now, and you change the return type. But yeah, I think where the inference falls short is like, I don't know, like say you say, return one. It's the inferred return type is going to be number, but then all of a sudden you have a like if if some condition return a string, and then all of a sudden your inferred type is string or number, and it's still inferring it properly, but like this goes to what you were saying, like no, my contract is only number, why is string showing up here now? And so that definitely makes sense. I definitely don't do it for like React components, just because typically the return type is, I mean,
Oh
unless you're
yeah,
doing
yeah.
like, but I do agree with you with like certain like functions, but like I guess it's also like I guess what the team decides to, but like I can see that being the case. Like I guess I guess I'm a bit loosey goosey in that sense. But it totally makes sense what you're saying, and it's kind of like it's not TDD, but it's a similar principle. Like, uh, you know,
Kind
you
of,
know,
yeah.
not exactly the same thing, but like this contract says like this function returns this value, even if you don't have the function written yet. Like you have the like the
Yeah.
stub of it, so kind of same principle. Like, but yeah,
I've actually had a
okay,
lot of success too in mentoring mid-level junior devs in like taking this approach where like I can design out like a whole feature and just stub out the function
yeah,
definitions or just use like the declare keyword, and then I can hand off tickets and like very minimal implementations to junior devs and just have them program against that contract. And like
yeah,
one, it's good for me because I know it's going to be built in like the right way, and two, it's a good learning experience for junior and mid-level devs because they get to see like, oh, this is how someone more senior would
yeah,
put together design the system, right? They're still in charge of the implementation. um,
yeah.
and there's plenty of freedom there, but like from an interface kind of level, I've had a lot of success with that. Another interesting thing about type systems like OCamls or Gleams or Reasons is that
Hmm.
you can only return a single type from a function.
Oh, okay.
And that might seem a little limiting, but the way kind of around that, and one of these languages like OCaml superpowers is sum types, or in Rust, they're called enums.
Yeah.
We would call them discriminated unions in TypeScript. That's how you basically bundle together different types. You'd say like, hey, this is,
Okay.
function or type A, right? And it has, you know, three or four different variants which represent the different types it can return. So that's
Yeah.
generally how that's handled.
Yeah. No, that's I noticed that recently. I I don't know about you, but like Swift UI. So for building like iOS apps, I thought Swift, the language, was literally just for building UI, and I discovered recently, like, and this is because I'm not in like Swiftland, and like I haven't really built mobile apps, but you can use Swift for backend. You can build CLIs within stuff, and I did some conference driven development. I submitted a talk where I don't know if you've heard. I, I'm sure you've heard of Zod, but there's another project called
Mm,
Valibot. It just similar idea, but it's like it has some niceties to it. Like there's a dot pipe and like there's some really cool stuff in it. But I was like, I'm gonna try and learn some Swift. So I've taken on a task of I submitted a talk where I'm converting Valibot to Swift, and
hell yeah.
yeah, haven't I started. I've done a bit of exploration, but like there's things I noticed out of the gate already. So like you have to use enums. You can't have discriminated union types. So like if like this string or this string, you just can't do that. It's an enum with different values and stuff, and so
Yeah.
kind of similar thing, and like in Rust as well, where you can have like the error and the value, and so okay, so basically it's you're still getting all those things. It's just like it's wrapped into a nice type instead of like a few
Yeah.
types
And
in the
then
return.
the couple sum types or enums or variants, whatever you want to call them across these different languages, you add pattern matching into the mix, and it's
Yeah,
just those two features together are a superpower, like
yeah.
just unbelievably good. I just pulled up my conference talk, and I think there's some interesting things in this that would you be cool if I just like gave like 5 minutes of this talk because I think it's
Oh
super
yeah, yeah, yeah.
relevant.
Go for it, man. If you want to share your screen, I can pull that in. Just let me switch over to our Twitch screen where we're at together. Yeah, just go ahead, share your screen, and I'll pull it in. Just
Can
I just gotta
you see
I
my
can
screen?
see it. Yeah, I'm just gonna pull it in OBS. Just one sec here. Let's see here. Guest sharing. Cool. Guest sharing screen. Just gonna make sure it's resized properly. Okay. I'm just gonna resize it slightly. Give me 1 second here. But while I'm doing that, you want to just kind of maybe just mention, I guess the preamble to the talk, and I'll just grow it a bit
Yeah.
here.
Yeah, so the premise of this talk, much like you, it was conference-driven development.
Okay.
When I was at Scholem, we did a bit of front-end work in OCaml and compiling to JavaScript, and we also had an Excel plugin that was written in OCaml and
Okay.
compiled the JavaScripts. So Melange is a compiler for ReasonML and OCaml to JavaScript, which, as a
Okay.
quick clarification, ReasonML is just an alternative syntax for OCaml. It still compiles to the same native code as OCaml. It can use all the
Okay.
packages in the OCaml ecosystem. Um, it just has a syntax closer to um, JavaScript and also has JSX built in. In fact, ReasonML was built by Jordan Walk, who is the same person who made um, React, maybe
Yeah. Okay.
unsurprisingly.
Yeah. Yeah.
Cool. So let me. So basically, this is just kind of at a high level, like what is OCaml, what is Melange, what is ReasonML, why would I want to use it?
Okay.
That sort of a talk. And so, two of the sections I want to talk about is the pitfalls of TypeScript's type system, and then I also want to kind of just gloss over some of the type system of ReasonML and
Okay.
OCaml, which I use Reason syntax in this slide. It's way more approachable for most people. So, okay,
Okay.
so I'm just gonna walk through these slides as if I was actually giving this talk. So
Yeah.
let's talk about TypeScript. TypeScript is a statically typed programming language. It has excellent tooling, and like quite honestly, I still even to this day think like the DX of TypeScript tooling is probably like better than most other languages. We have
Oh
it
yeah.
like
It's
really good
it's top
on the
tier.
tooling front. TypeScript can be gradually adopted. In fact, I think this is what led to its success back in like that 2017 to 2019 window because you had ReasonML coming onto the scene at the time. You also had Flow.
Yeah.
And I think that because um, TypeScript offered this really good story for incrementally adding it to code bases on top of the definitely typed repo, which was
Hmm.
just like caught on like wildfire of people in the JS community contributing types for everyone else to use.
Yeah.
Um, so that was a huge sell for TypeScript, right? TypeScript enables a better developer experience. This kind of ties back to our tooling. Obviously,
Hmm.
really good LSP support in our editors if you're not working in a monorepo.
Yeah.
And ultimately, TypeScript is a vast improvement over regular JavaScript. That being said, we have some bad news. TypeScript can be cumbersome and complex. TypeScript is burdened by JavaScript's warts and dynamism. The TypeScript team made a intentional decision for TypeScript to be a strict superset of JavaScript. So they have to be able to handle the
Hmm.
dynamic nature of JavaScript, and that's a large reason why it's a gradual type system and it's unsound.
Yeah.
TypeScript has a lot of escape hatches, right? Like any casting with as, function overloads, things of that nature.
Hmm.
Um, because of those features, TypeScript can create a false sense of safety, and ultimately, TypeScript is unsound. But don't just take my word for it. Anders Halsberg, who is just like the goat of programming language design and compiler
Yeah.
design. He's the lead architect of TypeScript. He architected C Sharp. He worked on Turbo Pascal. Like just a brilliant, brilliant person.
Hmm.
He gave a keynote at ICFP, which is the International Conference of Functional Programming, last year,
Okay.
which I was fortunate to be at. And he had a slide where he said, I mean, clearly, this type system is not sound, and it was never designed to be sound. And gradual type systems aren't. They may be sound in islands, but they're not overall sound.
Hmm.
And he described TypeScript's type system as erasable, gradual, structural, generic, inferable, expressive, object oriented, functional, and unsound. Okay, but what does unsound actually mean?
Yeah.
Again, we talked about this a little bit earlier, but a type system is considered sound if it guarantees that a program will not cause certain types of runtime errors, assuming the program type checks successfully at compile time.
Yeah.
So, what makes TypeScript unsound? We have some usual culprits, right? We have any type assertions, we have non-null assertions, we have typecast via type guards or predicates, which that actually has gotten a little bit better with TypeScript 5.5.
Yeah.
Um, so you may be saying, well, then if we avoid using these features of the language, then we'll have sound in type-safe code. And the answer is unfortunately not. So I want to just walk through this quick little code snippet. I'm gonna quiz you and the folks in chat on this here in a moment.
Okay.
So let me get this here. So we have this basic type account. It has a username, right, and then an is admin boolean on it. We have
Yeah.
this validate username function. You can imagine this might be like in a utils folder somewhere or something. It
Yeah.
takes some object that has a username on it, just validates that it has a length of at least 5. If not, there's an error. Otherwise, just returns the object back out to the caller.
Yeah.
Then you can imagine we also have maybe another util somewhere called just print record, which takes some object and we just pretty print it out. You can imagine this might be for like a debugging use case or I don't know, whatever it
Yeah.
might be, right? So then you can imagine this bottom block is like your actual application code, right? We create a new account, username DMM Mulroy is admin true. We validate the account, um, and then we just print the record out, right?
Yeah.
So this code successfully type checks and compiles even on the strictest settings of the TypeScript compiler, but there's still a runtime type error that will crash our program if we don't have like an error boundary or try catch somewhere.
Okay.
So I'm gonna put it to you in chat to see if you can pick out where the type error occurs here.
Okay. So input dot username, it's required. So like that length check should be okay, but fonts key and input okay, wait, print record, validated account, and it's record string for const key. Oh, is this the for in versus for of in terms of like no, okay.
That's not
Um
it. Good guess
let's
though.
see. Let's see here. So we get the key, and then we get the okay, so oh yeah, sorry. The is min is actually a boolean, but we're doing the string there. Uh, but
Yep.
yeah, and like you said, it's the type was correct. Um, and I'm curious why that. Yeah, I'm trying to think why this passes.
So this happens because of, I think, one of the worst mistakes in TypeScript called, and I'm not an expert on this, so like if there's any real like type system nerds out there, I'm probably gonna get bits of this wrong. But at a high level, the reason that this fails, which uh, I have slides here, you had correctly identified where this fails, right? Fails on this line
Yeah,
because we're trying to call trim on a boolean, and that's not going to work out.
yeah.
Let me just step through this.
I'm
I don't know
trying
if
to
I
remember why.
have.
Does it like
So
infer like the to string or something? I'm trying to remember.
it function calls in certain circumstances in TypeScript. Uh, so there's this concept in type systems called variance, and it
Yeah.
has to do with subtyping and supertyping. And like you can have a function argument that accepts a type that might be contravariant or covariant, and I forget which one is which, but one basically just means it can take supertypes of the type you outline, or it can take
Okay.
subtypes of the type you outlined. And then there is the actual culprit, which is bivariance. Bivariance is it can take a supertype or a subtype. So what happens
Okay.
here is record is technically a subtype or maybe a supertype, whatever, right? What we're passing
Yeah.
in
Yeah.
is not record string string. It's record string string or boolean. So yeah, it would be a subtype.
Yeah.
Um, and because of bivariance, it just like accepts it and everything's good. And like we could have prevented this problem if we annotated our type here, we would have caught it,
Yeah.
or our return type, um, or I guess maybe not. This just returns void. Yeah, disregard that. Never mind. Um, the other way you could correct this is by using generics here.
Yeah.
Um, because when you return this back out, it's actually narrowing this as well, um, to just username string rather than the full type. So technically, right here, this type is going to be this rather than this. Yeah, it's
Y- Yeah.
just little things like that will catch you sometimes unexpectedly.
Yeah, and like you
Let's
said,
see.
that's the kind of thing where it's like it's really not obvious. Like you probably
Yeah.
clue in eventually, but again, like yeah, build systems all good to go. It's like yeah. Anyway, sorry. Go on.
Uh, the other bit I wanted to show off is this is kind of just the syntax of ReasonML. An interesting feature is that like you have to use different operators for different numeric types. So we have plus for integers, plus dot for floats.
Okay.
Um, this is what would happen if you tried to do that. I'm trying to see here what would be. Oh yeah, this is kind of a good demonstration of how these languages infer types. So in the comments above here, I have what the type system is inferring these as, just like
Okay.
automatically. You can kind of see down here that we create a point and it's just a tuple of 1, 2. But because
Hmm.
that matches our type coordinate, it knows to infer that as a coordinate.
Okay. Yeah. No,
Let's
that's
see.
super nice.
And these are super
Right.
similar to just how generics and types work in TypeScript. Let's see here. In fact, yeah. So these two type definitions are identical from TypeScript to OCaml
Okay.
and ReasonML. So like if we have a generic functional programming languages generally use this tick A, which is like
Okay.
alpha for their generic rather than T. Um, but it's the same idea, right? So like here's the TypeScript equivalent.
Oh, okay. Yeah, I
Basically,
see.
super familiar. Yeah. Let's
Okay.
see. I want to jump to the enums and pattern matching part.
Yeah, pattern matching is something I wish we had in JavaScript. It's so
Yeah,
nice. Like
me
I've
too.
dabbled in it, and it's just like honestly from just like forget like practicality. Like from an aesthetic standpoint, it's really nice too. So
So nice. So variants or sum types end up looking like this, right? We have like some type and then it has a couple different constructors on it. So we have a yes, no, unsure. Let's say we have an event that represents like DOM events, right? Constructors
yeah.
can also carry data in them. So like a click event might have the X and Y coordinates of like a click, or a key press might have the character you pressed. But they're
Okay.
all like a click is an event, right?
Yeah.
So that can then power pattern matching. So you can effectively match on a type, which is different from how TypeScript's like switch type works. And then if it's a
Hmm.
variant, you can basically pull the data out of these constructors.
Okay.
So I think it's just a really nice terse way to see like how things are happening here.
Yeah.
Um, let's see here. So
Uh,
my light bulb moment with OCaml and ReasonML came from building um, basically this little. I was building on Stream originally this project to transfer playlists between Spotify and Apple Music, and
okay.
as part of that, I had to do like OAuth authentication. And the way I
Yeah.
do that is I did it from the command line. So what would happen is I'd spin up a little temporary HTTP server, and then I'd open the user's browser to
Okay.
authenticate, and the redirect URL would be pointing at localhost. So it redirects to
Okay.
localhost, hits the web server, we pull the credentials from that. So that's kind of what we're
Cool.
getting ready to look at right here.
Okay. Cool. I just gotta interrupt for 1 sec. Thanks for the raid, Will the Foolearn. Thank you. Nice for joining. Thanks for joining us. Sorry. Okay.
Welcome,
Yeah. Go
Raiders.
on there. Yeah.
So this is basically a direct copy paste of the code where I was like, holy shit, like this is so different than TypeScript. Because like again, until I worked with OCaml, like my perception of what types meant and type systems were was TypeScript, Go, and Java. And I didn't think there was like I thought
Yeah.
that's what it was. Like there was nothing else. This is how it has to be. This is how it is. And that's just so not true. So again, I have this comment here. The type system is inferring the type of route handler to be a function that takes a request T, which is just like saying, imagine you had a type called request. It's like practice in OCaml to like name your types like some type dot T.
Yeah.
So it takes a request and it takes a string and it's going to return a result where the OK solution is a string and the error um, variant is basically just a message with a string in it.
Okay.
So the type system inferred that like perfectly from how we use it down here. So we get a request, we get this, we pull some query parameters off of the request, and then we switch on path, which is just a string primitive, and we say, okay, if we hit Spotify, we're going to drop it down into another pattern match, and we're going to pattern
Mhm.
match on both the code parameter and the state parameter.
Okay.
These are actually option types, which are similar to result types. They're how we model null or undefined in OCaml and Reason.
Okay.
There just is no null or undefined. So we use option types, and options are similar to result in that it has two variants. It has some with data in it or none,
Mhm.
meaning there is no value. So both
Okay.
of these are an option. So we say if code param and state param are sums and they have data in it, let's pull the code out and the state. And then we can also add a condition on this pattern match. When the state equals the server state, which is basically a CSRF token, are equivalent, we can return the code back out to the caller and we properly authenticated.
Okay.
However, if we get data from both of them, but the CSRF token doesn't match, we got invalid state. Maybe we
Okay.
got the code, but not some state, there's state received. And like just being able to like so tersely and succinctly like lay out all of the
Mhm.
possible things here. And like if I missed one of these, the type system would yell at me. Like it has to be exhaustive in
Yeah.
handling all your cases. So this is like kind of where I was like, wow, this is
Yeah.
incredible. I love pattern matching.
I'll just
So
interrupt you for one sec there. Fuzzy in the chat saying multi-switch. Now I'm sold, and not sure who Rebus V is, but they say, "Hey Dave, how's it going?" I'm not sure who the Dave is, but anyways, yeah. Sorry, go ahead.
So the last bit of this presentation, I kind of want to show off is like the basics of how this type inference works. I talked about a little bit about it before, but just yeah. So let's demystify Hindley-Milner. So we
Okay.
have these two functions, let foo, um, pretty basic, passes it to string.length, and then we have a bar that takes an x and y, passes x to foo, and adds y.
Yeah.
So I'm going to put you to the test again. What do you think the type of S is?
Okay. So, uh, looking at foo, it it. I would assume it's a string because it seems to be like this is it's not like it's kind of it looks like kind of like apply in JavaScript to say like apply the length property to some string to get its value. That's what I would read the return type as. Sorry, the the parameter value as. I don't know if that's right, but
Yes, it is. It is a string.
okay.
So what about the type of X?
Okay, so uh your camera's cutting off part of it, but it's foo function foo x plus y. Is
Oh,
that what it is?
yeah. Let me move this over a little bit there.
Okay,
Does
cool.
that help?
Yeah. Okay, so xy here. So like assuming string is sorry, assuming based on foo up top there that x is a string, we're gonna get a length back, which is a number. So it should infer. I'm assuming the compiler would say like y has to be a number, otherwise you can't add them. Just guessing.
Yes,
Okay.
exactly.
Okay,
So
so that,
X is
that
a
that's pretty
string.
intuitive though. I think.
Yeah, exactly. So how do we figure those out, right? And the way Hindley-Milner works is like basically the same process you just stepped through right there. Like you looked
Okay.
at the usage and you figured it out, right? So I'm annotating these types with question marks in this. So if we start with S, right, we see that S is passed in here. It gets passed to string.length. And if we were to look at the type definition of the string.length function, it is a function that
Mhm.
can only ever take a string and will only ever return a integer.
Okay, yeah.
So we can accurately infer that S has to be a string and that the return type has to be an integer.
Okay.
So moving on, looking at X, Well, we've already done the hard work of figuring out what S is into foo, and we know that goes into there. So X can only ever be a string. Next, looking at Y, we see that there was a plus, and I briefly touched on this earlier for this purpose, is
Yeah.
that integers can only ever use the same operator. So like a plus has to work with integers. And we
Okay.
know that foo already returns an int. So this must be an int. And therefore this must return an int, right?
Okay.
So that's kind of
Yeah.
like at a basic level how the type inference system works. And you can kind of like apply that to like if there were properties we were accessing, kind of how I
Mhm.
talked about earlier. And we can also annotate our types as I talked about. And like oftentimes in these languages, I still do because it's helpful for documentation purposes and clarity. Um,
Yeah, for sure. No,
but
that's cool.
looking at the same example in TypeScript, um, we get these type errors from the compiler if we leave off our
Yeah.
type annotations. It just doesn't have the inference capabilities. Um, And you might say, like, oh, well, in the first example, string.length was a function that was strongly typed. And even if you duplicated that and made string length this super strict annotated function, you're still going to get the same problems.
Yeah.
So that's just kind
Yeah.
of like at a super high level. Like, I just stopped sharing my screen, by the
Yeah,
way.
yeah, I'll
If
bring us back then.
sorry,
No, 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 it's all good. No, that's super cool. I guess, like, this is really cool, but like everything, there's trade-offs. I'm curious, like, because you've been working with OCaml for a while, and I also kind of want to dig into a bit like who's using OCaml, because like I know it exists, and you
yeah,
mentioned a company you worked at was using it, but it's definitely not as well known as like C Sharp, Java, or like
yeah.
TypeScript. But to the first question, like, you know, it sounds all amazing, but is there any gotchas, or like what are things about OCaml that you're not a fan of, or maybe there isn't anything, but just curious.
So OCaml is in a place where its ecosystem is its biggest um, downside. I describe the ecosystem as relatively Spartan. So you'll find that a lot of times you're going to have to roll your own solutions just because there's not the plethora of packages that might be in the
Okay.
Rust ecosystem or otherwise.
Okay.
Um, Beyond that, there's a bit of a learning curve with the syntax, but you get past that pretty quick. And I've actually learned to prefer ML syntax without the
Okay.
braces and parentheses. Um, yeah, I would just say the tooling in the ecosystem is like the one real downside of OCaml, and it makes
Okay.
it hard to just recommend across the board if you're not interested in the um, upsides, which I think are very valuable and are worth the evaluation. But um, yeah, it's
Okay.
hard. It can be hard and frustrating on that front. There's a lot
Yeah.
of work going on by a lot of brilliant people, a lot of people I consider my friends working to make the ecosystem better. Jane Street's doing some interesting stuff with the compiler where
Yeah, that's what
they
Fuzzy's
are,
mentioning in the chat.
yeah, so Jane Street is like the poster child of OCaml, like one
Okay.
of the most successful quant trading firms in the world, or I think that's what they do. They use OCaml for everything. They use OCaml for
Okay.
embedded hardware. They use it for their trading platforms. OCaml is super fast. Like if you just write normal OCaml like out of the box, you're talking at like getting speeds like 50% the speed of C. Like generally you're going to be in the ballpark of like Go, maybe a little bit more performant than Go,
Okay.
especially on how OCaml does garbage collection opposed to Go. Um, but Jane Street is working on adding the ability to opt out of garbage collection at
Okay.
like constrained parts of your code, and basically embracing Rust's like view on the world of like locality and ownership and borrowing. So you'll be able
Okay.
to like mark functions and types as like this is going to be in a section of code that's going to be like all sharing the same call stack. And
Yeah.
uh, yeah, it's I'm really excited for that to land because then you're talking
Okay.
about getting Rust speeds with OCaml.
Yeah,
And
that's pretty
OCaml is
cool.
just so much easier to write. There's so much less ceremony in writing OCaml than there is uh, a language like Rust.
Yeah, no, it's interesting what you're saying about the garbage collection because like the thing with garbage collection is like it's great. Like I mean, I did C sharp for years. Java garbage collects as well. So does Go. And like eh, the problem is at some point you get this hit where it's like literally like the garbage truck coming around the corner. Okay, I actually have to pick
Yeah,
things up now, and then you get that blip kind of, and
yeah. Go's
which could be
notorious for
crucial.
that too.
Yeah, and it's this.
I think it's Discord has a bunch of really good engineering blogs on like tuning Go's garbage collector.
Okay. No, that's super cool. This is somewhat related to the garbage collection story, but I was fresh the the React Meta framework from the Dino folks.
Mhm.
I was talking with Luca over there. This like almost 2 years ago, but like um, I remember reading about Dino. It was originally written in Go. That's how Ryan Dahl started it, and then I was curious. I said like, "Oh, why did you switch to Rust?" And he said the problem was so Go has a garbage collection like you were mentioning, but when they're interacting with V8, it was doing some garbage collection as well, and you had competing garbage collectors at some point.
Mm,
And so basically, they said we're switching to Rust, and that brought some other benefits like WASM and all that stuff. But I just found that kind of interesting. Like that's not something I would have ever thought of, that you'd
yeah,
run into, but clearly they did. But and that's a little side tangent there. Um, but yeah, it's also interesting because uh, I was hanging out with somebody from the Vapor team. It's a Swift web server, and they were taught because I'm just curious about Swift now because they've got some functional programming concepts in there, like we were kind of talking about briefly, and they have this concept called arc. So it's automatic reference counting, and I found that super
yep,
fascinating because it's literally like you allocate something. Okay, it gets marked as one more on that whatever that thing is. And
yep,
the thing I found super fascinating about it is like like using like weak maps or weak sets, which I do use occasionally in JavaScript. you know
yep,
they, they just disappear as soon as whatever it was referencing is gone. And I find like it was so simple but so smart in the automatic reference counting. They're like, oh, it's a weak reference, just don't increment the counter, which I found just pretty cool.
yeah.
And anyways, yeah, it's different way of doing
Swift
things
is one of
obviously,
those.
but
I haven't gotten to use Swift at all, but I have heard people praise Swift similar to you, and it just like I wish it wasn't so tied down to the Apple ecosystem. Like I think it sounds like it would be a language I would love to write software in.
yeah,
Yeah,
no. But the funny thing is, so like this getting back to what I was saying before about Swift, where I thought it was literally just Swift UI, but it's actually cross-platform. I didn't know this. Like because I don't know about you, like I've got a Mac, I've got an iPhone and stuff, but I'm not typically a fanboy watching the developer conferences.
same. Yeah,
I catch the recap, but I just happen to come across like some Swift stuff, and you can build like backends, CLIs, and it's cross-platform. It even works on Windows now. You can use VS Code for writing Swift. Like that's how I've started to write it. So all
oh,
that to say is
interesting.
like if you're interested in it, it does work on Linux and Windows. I think Windows still needs a bit of love, but like uh, yeah, it's just like I said.
That's an
I
evergreen statement.
Yeah, yeah. Yeah. I don't know. To that, I always just say just use WSL. Like not that I'm on Windows these days, but that's probably what I would do if I was on a Windows machine. But
Yeah, maybe
anyways,
I'll have to check it out on stream some morning.
yeah.
Um,
But no,
yeah,
that's
it's
super
just
cool.
like I'm giving a conference talk next month in South Carolina at Carolina Code Conference.
Okay.
Basically, like introducing Gleam and talking. Like the first half of the talk is going to be about just like my journey through programming languages, features I found useful, things I like, and like the that core premise of the game. There's like 4 or 5 languages out there that are so damn close to being ideal and close to perfect, but there's just like
Yeah.
an annoying trade-off with somewhere, right? Like OCaml, the ecosystem is brutal and the tooling isn't as good.
Yeah.
Rust dealing with async and lifetimes and the borrow checker can be more than you want to deal with.
Mhm.
Go, the type system isn't stellar. Like there's no sum types, pattern matching, stop the world garbage collection. It still has basically the any type with empty interfaces.
Yeah.
TypeScript, just kidding. Um, like there's just like all these languages. Swift, like Swift is another language that I feel like I would also love. But Gleam, which are you familiar with Gleam?
I will become familiar next week. I'm hanging out. I don't know if you know Jay Larkey on Twitter. He's
I've
gonna
never
be
spoken with him in person, just online interactions.
yeah, same here. He's gonna be teaching me about Gleam, and we're gonna because he did this some Gleam, some Go, and he's talking about using RSCs in Go, I think. So I don't, but yeah, I'm gonna get introduced to Gleam. But yeah, I'm curious your thoughts on Gleam.
Sweet. I will save your listeners some too many spoilers, but Gleam is very close to being my ideal programming language.
Okay,
It's missing a couple things, but it's like just about there. So Gleam
okay,
is a sister language to Elixir.
okay.
It runs on the Erlang virtual machine, and it can also compile to JavaScript and also generate
Oh
TypeScript
wow,
types during that compilation process. So it's got like this dual target of going to
yeah,
JavaScript and TypeScript or going to the Erlang virtual machine, which
okay,
Erlang and OTP, which is like the super scalable framework that Erlang uses for like everything, like is one
okay,
of the like greatest engineering feats of all time. Like there is no better concurrency story in any ecosystem than OTP for Elixir, Gleam, and Erlang.
okay,
Um, so you can think of Gleam being a sister language to Elixir, where Elixir is dynamically typed, which they're working on adding types. Remains to be seen how that will go. I'm optimistic, and I would be stoked if they nailed that
okay,
because the PhDs they have working on Elixir's type system are. Let me take a step back. Much like JavaScript, Elixir
hmm
started dynamic. JavaScript started dynamic. JavaScript got a type system through TypeScript, which, as we covered earlier, gradually uh, it's a gradual type system. It's not sound and structural based. The type system that the Elixir team is going for is this type system called set theoretic types, and it's based like
okay,
all around set theory. And on paper and research papers, literally, the PhDs working on this are kind of claiming that they're going to be able to get a sound, gradually typed type system on top of a dynamic language, which has never
oh wow,
happened. And if they land that, like Elixir could have a very bright future, in my opinion. So yeah, that was just a random side tangent on that. But
no, that's
Gleam,
cool though.
Gleam is a statically typed language, and it uses the same type system as OCaml and ReasonML.
Okay,
But Go is very also inspired by like the principles. Excuse me. Gleam is very inspired by similar principles of Go, where it's like keep it stupid simple. Like make it easy to do the right thing, make there be one way to do anything. And like
okay,
Gleam is just a very small language, but I think Gleam is without a doubt the best way to learn functional programming. I
okay,
think syntactically, it kind of looks like Rust without the borrow checker, and then you get OCaml's type system. You can
okay,
choose to compile to JavaScript and generate TypeScript definitions, or you can compile to Erlang and then get the wild, crazy concurrency and story that you get there.
yeah,
Where Gleam's downfall is at the moment is that it doesn't have a native compilation story.
okay,
So things like CLIs or anything that you would want to compile down to a binary, it's kind of a non-starter at the moment.
okay,
Um, Running Gleam in a serverless environment just isn't really going to happen.
Okay.
You could compile down to JavaScript, but then you're just running Node, right?
Yeah,
Um,
yeah.
but you get the guarantees of the type system, which is a good thing. Um, so if it got a native compilation story, like man, Gleam would be about perfect. Same with like Elixir. If Elixir lands this type system, like I would probably go all in on Elixir. Um,
Okay.
I love Gleam for sure. If anyone out there is interested in FP, go to Gleam's website and just go through the playground. It's
Okay.
fantastic. Um, yeah,
No, I'm definitely gonna check it out. And like I said, I'll be talking with Jay Larky about it. But yeah, the Elixir, it's I don't mean to be naming all the streams I've done recently, but I was hanging out with a friend from a community I'm in, Virtual Coffee, and he works professionally in Elixir, and so he kind of gave me the tour, and we were going through like he gave a conference talk, and he was just basically made like a game kind of like Tamagotchi, and he was just showing how like it I forget what the system is called, but like basically you can spawn tons of threads and they're so
that's
tiny.
OTP.
Okay, okay.
Yep, that's
Yeah.
OTP. They call it like
Yeah, like
gen servers and processes and
yeah, Gen
mailboxes.
server, that's what he
It's
was mentioning. Yeah.
it's basically the actor model if you've ever heard of that. Like, um,
Yeah. Yeah, I feel like David Khorshid's gonna show up now. Um but yeah, no, it was just pretty wild. Like I think he was saying they were like a couple bytes each, and like even on his machine he was able to like, I mean, given it was probably a solid MacBook Pro, but like spin up. I don't think he did a million. He was talking about people who do millions of them in production, but I
you
think he
can,
said like
yeah, they're so
he
cheap.
easily, yeah, and he said he easily spinned it up with like I think 10,000, and it like everything was fine on his machine, which is
Yep,
I don't know, which is kind of mind-boggling, especially when you come from the front end world where I mean, or just like full stack node, like you're used to like heavy
single
heavy
threaded event
things.
loop.
Yeah, yeah, single thread too. Yeah, so I don't know. It was just pretty cool. And then again, like you were saying, concurrency model, like they there's no issues there either. I think he was saying you can like if you want to share some state, there's not escape hatch, but there's just a different way you do that.
Yeah,
But
it's message passing. So each process in OTP, so whether you're using Erlang, Gleam, or Elixir,
okay,
the those processes that you can spin up millions of, they're what will be referred to as like green threads. Like Go routines are the same thing. Tasks in Tokyo and Rust, same thing.
okay,
Um, each process gets a mailbox, and you can basically send messages to other processes mailboxes, and they can receive from them, and that's how
okay,
you pass data back and forth between all these millions of processes if you need to.
okay.
It's really really cool, like especially if you're just used to building in Node, like
Yeah,
building a backend service in Elixir will like blow your mind as a Node developer. Just
yeah,
because of like you have to bring in so few dependencies because it has like term storage or like in memory caches like you use like Redis or something for, just out of the box built into the system. It's it's great. Um,
yeah.
that's also why like I like Effect for writing
Hmm.
um, backend services with Node now, because it brings in ideas from functional programming. One, everything is basically using the result type. So
Yeah.
you have a success variant, or you strictly say your errors. And my biggest hot take right now, I think, is that Node and TypeScript is the best language and ecosystem for being quickly, um, not proficient, quickly productive and building stuff, and then you can
Yeah.
move quickly and you can get stuff built. But I also think, having worked across many different languages and ecosystems now, I think specifically Node and TypeScript on the back end, I think building reliable,
Hmm.
maintainable, and scalable in the sense not like hardware or computing scaling, but like engineers managing code
Yeah. Yeah.
scalable. Like it is the hardest ecosystem to build reliable software in. And I think it takes a very, very high degree of discipline and expertise to build proper TypeScript backend services. And not a lot of teams or engineers have that level. So that's my hot take on TypeScript.
Yeah, yeah,
But
no, totally. That's it's a good take
Effect
though.
adds Effect adds a scheduler so you can get green threads like Elixir or Go or Rust have, which
Okay.
is interesting. So you can basically get the same concurrency model, which makes it a lot of fun.
Yeah. And I won't lie, I've definitely fired off promises and just like, happy path it. There's still
Yeah,
observability
yeah.
in place, but yeah, just so I don't sound like a hypocrite if I agree with you. So like, yeah, I definitely done that. There's a
Oh,
question
me
in the
too. Like
chat.
it's
Yeah. Sorry, go ahead.
oh,
Uh,
I was gonna
oh
say,
yeah,
like to your point, thinking about Happy Path, like that's the crux of the issue is that Node makes it so easy and TypeScript makes it so easy to only ever think about the happy path
yeah,
that it's just so easy to neglect. Like, okay, I'm in a function 3 layers deep in my stack, and I know this promise can reject, but we're just gonna throw the error, and it's
yeah, yeah,
somebody else's problem up the stack, right? And there's no help from the type system to tell you that a function might throw or not. So you
yeah,
basically, if you want to do it right, like you just have to be hyper defensive, and it's very challenging. I If people aren't like interested in Effect TS, I would at least encourage y'all to check out Never Throw and like
Oh,
just give
never
that
heard
a
of that.
shot in one of your. It's
Is that a
basically,
package or is that a
yeah, I'll
okay?
link it in both Twitter and Twitch, but it's a package
Okay.
that brings basically Rust's result type into
Oh, nice, nice.
TypeScript. Drop it there,
Yeah,
and I will drop it right
I've kind
here.
of done that in a like a not naive, but like just when we call some API stuff, like we're using like I was telling you before, we're using Next.js and like our hooks are using like SWR. That was what was there before. Like maybe if it was now, we would have used React, the tan stack stuff.
Yeah.
But yeah, when I make some API calls, I'm there like if there's an error, I return an object with an error and the value,
Yep.
just because and this is kind of super crucial, and we'll get to your question in a sec there, Alex. Because like in React, at least, like if you're building front ends with React, there's the error boundaries, but you have to kind of import that now. You used to be able to get that with class components, but you don't have that now, so you have to like we're using Sentry, so I use their error boundary
Hmm.
one, but it's you get like the PHP white screen of death as something just throws and you're not handling it in React, which can be very like foreign to somebody who might be even just new to it. So it's like,
Yep.
so yeah, but yeah, let's get to Alex likes coding's question. Can I ask about Next.js? I love using it, but I'm only used to using it in a group where it's already started. Trying to start my own project with it, but now I can't get past this error with login navigation. I don't want a login page. Uh, I don't think we can really address that on the stream because we need more context and stuff. But um, I'd suggest if you have a public repo, maybe kind of throw it out to this Twitter sphere if you're kind of stuck. Um, but yeah, it's kind of out of not to sound like stand up style, but it's kind of out of scope or what we're talking about right now. And actually, Dylan probably has used Next.js, but he actually doesn't work on the Next.js team. So, but yeah, I'm guessing it's something in user land. Just see what the logs are given and check the dev tools for the console errors and stuff. Or if anybody in the chat wants to lend Alex likes coding a hand, go for it. Um, uh, read I don't know how to say it. Read ISV saying uh, uh, they really love it. I'm not sure what they're referring to, but oh, maybe it's the never throw. I'm not sure. It's kind of out of context chat because I don't know when they actually asked it. But anyways, But this is super cool, man. There's like, uh, there's been all kinds of cool stuff you've been working on, and there's like definitely some stuff I learned here today, like about like the OCaml compiler and stuff. And oh yeah, I remember. Yeah, when we kind of touched on it, you were saying Jane Street is like one of the main places using OCaml, uh,
Yep.
but aside from them, it's not really like a mainstream thing. Still, it's definitely got a niche following, and but to your point about like the ecosystem and the tooling, I think that's not a negative thing. I think that's don't worry about the doggo. Yeah, I'm assuming that's your dog, but
Yeah, yeah. Hold up. 1 second. Let
yeah,
me
yeah.
get them quiet down here.
Okay. Um, yeah. Anyways, while Dylan's back, oh, the link posted by Dylan was immediately deleted by bot. Oh, okay, sorry. Yeah, it's this one. I'll drop it. I apologies for that, folks in the Twitch chat. I installed Nightbot recently, and it's like very aggressive. I need to tweak it, so I just dropped the link again that Dylan had there. So it's called Never Throw. I'll just see. Was there any other ones? I don't think there was any other ones. Yeah. But yeah. Um, uh, but yeah. Yeah. No, what I was saying was, I don't think it's not really a knock against OCaml. Like the ecosystem not being there yet and the tooling. It's just it's a newer language. So like, you know.
Actually, it's an old language.
Oh wow. Okay. Okay. My mind's getting
OCaml
blown
was
now.
made in 93, 94, 95, somewhere
Oh
there.
okay.
So it's been around, and it's actually was born out of kind of this long lineage of ML, meaning meta languages, that started like way back with like literally lambda calculus.
Okay.
So it was basically born out of that, and it went to, I don't know the exact lineage, but went to ML, standard ML, and then from standard ML, OCaml was born.
Okay.
And what kind of has been driving some of the noise and popularity around OCaml over the past year or two is there was a major version release a year ago, year and a half ago,
Okay.
5.0, and they, I believe they dropped the global interpreter lock, and they added multi-core. So multi-core in an effect system, which
Okay.
we can talk about effects in a second, but getting multi-core before it ran like Node.js, single threaded. You could use schedulers that were built to get kind of green threads, but now like it's built into the language.
Okay.
So that is like a huge monumental feature, um, and so that's driven some of it. And then effects are super interesting. I don't know if you've ever heard the term like algebraic effects, but they're
Yeah, yeah, they talk
I
about it in React all the time, like in the
yeah, think
earlier
about it.
talks.
Well, suspense is basically like a poor man's version of algebraic effects. You throw a promise and then you
Yeah,
resume to it somewhere else in the call stack. You can think of like algebraic effects, and I'm sure somebody who knows functional programming, like I definitely am not very strong on like the math and theory side of this. Like I think
yeah,
the practicality of functional programming ideas are really powerful, and like it's influenced how I work in TypeScript and other languages.
hmm
But you can think about algebraic effects as like kind of like throwing strongly typed types and then being able to pattern match on them and resume those effects at different
okay,
places in the application. So, like in React, for example, you're loading data and you throw a promise, some suspense boundary way up. All that suspense is a try catch that then catches that, checks if
yeah,
it's the promise, and then just awaits. And when that promise resolves, it basically runs the dot then off the promise, and that's
yeah,
like resuming like you would in an about algebraic effect system. So an interesting idea how like I think it's really cool how React and a lot of these popular libraries that we have in the TypeScript ecosystem have like not necessarily quietly been introducing functional programming concepts, but like
yeah,
think about like React immutable data, like isolating side effects, like all these things.
yeah,
Yeah.
totally. Yeah, and it's kind of funny because like you were saying, Anders created C sharp as well as Turbo Pascal. So like a lot of the stuff, like side note for me, going to TypeScript, the learning curve was pretty easy because I had already
Yeah,
done generics in C sharp. I think generics are something that throws a lot of people off that have never seen it.
yeah.
Um, but I lost my train of thought. Of what were you saying a second ago again? About
Being exposed to functional programming concepts through
oh yeah,
React.
yeah, yeah, yeah. Okay, it'll come back, but yeah, it's still a wild concept that I'm pretty sure it's Sebastian. I don't know how to say his last name. Is it Mark Boge or Mark
I
Badge?
admittedly also don't Mark by yeah, I don't know how to say it either.
Okay. Anyways, but
But
like
a genius
it's
also. Legend.
yeah, but it's pretty wild. Like, hey, why don't we just throw a promise? You know what I mean? Like that's not something that usually you think about.
Yep.
So it's
Yep.
just
Very novel
pretty
in
interesting.
the JavaScript world for sure.
Yeah, yeah. Cool, cool. Well, listen, I know we're almost at time here. I'm just gonna see if there's any other questions in the chat. Okay, yeah, no, Reeves was just, yeah, like I was saying, Nightbot uh didn't let you post that link for some reason. I gotta configure Nightbot, but yeah, no, this is honestly super cool, man. Like, I we went on all not tangents, but we just talked about all kinds of stuff in FP, and there's a lot of I definitely learned some things today, and it just well, I don't know. I always say this to people because like people like I know the job market's kind of in the toilet at the moment, and like people find web dev tough sometimes, but like and granted, I've been in the industry for a while. I feel like we're like so lucky with so many of these amazing things right now. It's like I definitely do not miss the days of having to configure Webpack and just working with all kinds of other stuff, and
Yes.
like just all these cool languages now and just DX and tooling and oh my god, it's like I don't know. I just think, whenever I hear people complaining, I'm just like it's amazing. I don't know. I don't know what your thoughts are there like
Is
in a
we
in a
are
nutshell.
definitely like at the best time to be not even just in web dev, but like in software,
Yeah,
like
software in general.
period,
Sorry.
like
Yeah.
across the
Yeah.
board, like every things are pretty good despite even my own complaining.
Yeah, no, totally. Cool, cool. Well, that's awesome. No, I just want to thank you again, Dylan. This was awesome hanging, and maybe we can do it again some other time. Uh, Thanks
Yeah, that'd be
everybody in the
fun.
chat, and I'm just gonna drop a link to the schedule. I won't be on my own stream tomorrow, but I do a monthly thing on the CFE Dev channel, and we're just gonna be working on building out a browser extension. I used to work at McAfee and worked on their password manager browser extension, so familiar with that space. And I thought it'd be fun to just build one out. I don't know what we're gonna build yet, but if folks want to check that out, you can check the schedule. And yeah, maybe we'll see you tomorrow. And if not, enjoy the weekend. And Dylan, if you don't mind, just staying on for 1 second. Everybody else,
Yeah, no
take care.
problem. Thanks, y'all.